based on virtual machines, based on sandboxes and sandnets. And then, of course, we have our own sandboxes too, and we use that for detecting malware and helping analysts to collect information about changes in the system that malware does based on virtual machines. So sandnets are actually they connect different sandboxes and make like virtual networks made of dedicated virtual machines. There would also be no emulators, and there are different companies which are using emulators approach for consumers and in the lab in-house, like Bitdefender, Norman, and we do use emulators massively. This is something very similar to virtualization, but the difference between emulator and virtual machine is that virtual machine actually emulates hardware, but emulator can emulate presence of software as well. Like making malware believe that in this environment which we use to execute malware in, there are plenty of different security solutions, and if the malware is trying to kill one of the processes in this virtualized environment, we will spot this activity and we will detect it as a malware. And there would have been no automatic malware detection, which is so widespread now. And to show you some stats, we daily detect from 200 to 500 different malicious files manually. We have various analysts who just check the files, check emails coming from users and other sources, and add up to 500 signatures per day. And in our automated detection system, we can detect 10 times more. And all these systems are using virtual machines and sandboxes to extract this information automatically. And also, last year there was introduced a very nice approach, which actually uses virtualization and helps you to reflect malware. It's not like anti-malware detection system. It does not detect any malware on your PC, but it changes settings on your PC so that malware will not want, so to say, to execute on your system. The idea came from Xu Chen and Andrew Lee, and this idea was introduced last year at a couple of conferences. And the idea is very simple. Malware writers, they usually detect where the application is being executed. And if it is a sandbox, if it is a virtual machine, they detect it by different traces in the system, by checking hardware, checking vendors of hardware IDs, and if this virtual machine, they will not run. So malware will not execute on virtual machine. There are plenty of such examples, and we have it in the lab. And the idea was simple. Let's create these traces of virtual environment on a real system. So just take a real computer and create everything that actually shows that this computer is not a real but a virtual machine. And the malware will simply not execute on that system. So this is an idea which is also based on the influence of virtualization and how malware writers actually treat virtual machines. And this helps preventing infections and preventing malware propagation on some systems. And well, I'm missing one slide here, but let me just repeat what I have already said and make another example of using virtual machines in virtualization. So we use virtual machines for fast experiments, for sandboxing and building sandnets, for emulators approaches. So we use malware reflectors, as I said, and also this last thing, malware authors make mistakes because of virtualization influences their mindsets, and I will explain you how. Last year we have seen a very big threat, which was called Trojan ransom GP code. That was a Trojan which encrypted users' data with the strongest cryptographic algorithm. It used RSA for encrypting users' documents and photos and other files. and there was no way to decrypt to get it back. And there are a lot of users who suffered from the Trojan. And we managed to crack this encryption. And in fact, RSA with the key length that was used was uncrackable theoretically. But we managed to crack that in because the malware writer, malware author, worked on a virtual machine when he tested his malware. And working on virtual machine, he used some special counters, hardware counters in CPU. And based on that counters, he generated unique data to encrypt the files. But on real hardware, this data was not so unique. It was not random. It was predictable. So when it came to real hardware, we were able to predict encryption keys for that Trojan, and we were able to crack and decrypt users' files. So here you can see, if there was no virtualization, we would have never been able to decrypt this Trojan, to decrypt the user's data, to crack this Trojan and encryption. And we have virtualization, and thanks to that, we utilize it. We, learn how it influences our writers' mindsets, and we use it to help our customers. So yes, we want all of that, all types of virtualization and the consequences of spreading these approaches. Thank you very much.